All right, so we're talking about factoring. It's section 4.1 in the new book. It is section 5, no, excuse me, it's section 5.1 in the new book. It is 6.1 in the old book. All right, again, some people have different editions. When we factor, the first thing you got to know is if you see four terms in the problem, that's going to be factored by grouping. So in a problem that has four terms, just know that at some point you're going to have to invoke grouping, at least for test 3 in this course. All right. So problem number 1 was x to the 5th minus 2x to the 4th plus 6x cubed minus 12x squared. You don't want to factor by grouping right now because there's something common to all of them. And the bottom line is this. You always have to search. You always have to search for common factors first. You always have to search for common factors first. Now, here's the thing. Most of the time, there is no common factor. I mean, probably 5 out of 6 times, you don't have a common factor. It'll just, and you'll be okay. But that 1 out of 6 times that it does, you're going to miss it. So you always look for a common factor first. When I say that, recognize that the common factor could be a number that's common to all 4 of them, or all 3 of them, or all 2 of them. Or it could be a letter, and in this case, it's a letter. X is common to all of these. So we're going to take out the smallest exponent. So we're going to take out x to the 2nd, and what we're going to be left with is x cubed minus 2x squared plus 6x minus 12. Do we agree? Now, once you get to that point, you cannot be satisfied there. Once you get to that point, you have to group these together. So you're going to have x squared on the outside, and then in this piece, you're going to factor these 2 pieces. What's common to those is x squared, and you'll have x minus 2 left. What's common here is 6, and you'll have x minus 2 left. Once you get to there, again, keep in mind that these 2 are supposed to be the same. If you've done it correctly, they're probably going to be the same. So x minus 2 is common to both. So the x minus 2 would come out. The x squared would stay there. And what you have left is x squared plus 6. Okay, what's wrong?
Why'd you do that?
Yeah, I did
Why'd
it.
you take it out? Like the
Where?
yeah.
I did it a little
I
bit
just did
different.
it the other way.
I swear it's right. I swear my way right.
For those of you watching at home, we do have a student who is now swearing that his answer is right. I won't tell you who that person is. I'm going to keep the name out to protect the innocent. Well, that was quick. Here's what happens. A lot of people will take this expression. And they will just straight split this in half. Call this x to the 4th, x minus 2. Call this x squared, 6x squared, and get x minus 2 here. Then get x minus 2, x to the 4th plus 6x squared, and then they'll swear that they're right. And on some level they are. I mean, make no mistake about it. On some level they're right. But not on the test they're not. And the reason is because there's a common factor between the x squared and the x to the fourth here. And so you'd have to deal with that. Remember, if you remember nothing else that I tell you, you cannot have common factors in a parenthesis. It is not, cannot, will not ever be right. The point being, if I gave you 24x plus 72y, some people will say, well, take out a 2, you get 12x plus 36y, and they'll swear they're right. I mean, they'll look at it and go like this, no, bullshit, I'm right. And I'm going like this, no, I'm not, bet. I love the students who bet wrong shit. Like, that's just the funniest thing in the world to me. Like, I'll bet. Okay, I'll bet whatever you want. And they go like this, I know it's right because look, that's 24, that's 72. I know I'm right. Look, I mean, shit, put a 1 out there and call it good. And be like, well, 1 and 24 and 72, that's right. I multiplied out, it works. What I'm saying to all of you is that just because you're able to factor out something, it doesn't mean that you factored it completely. And your goal is to get it completely factored, not just a little bit. Does that make sense? So, to your extent, that is this, if you multiply it out, will it get you back to where you started? 100% I agree. And if that's the way you test whether it's right or wrong, 100% I agree it will get you back to the right answer. What I submit to you is it's not factored completely because you did not take out the x squared here.
How do you know when to do that?
That's a good question because now some of you are going like this. Well, yeah, way to just show it to us and never show it to us. Like you act like we know how to do that. No, I mean, I know it's a struggle. If there's anything common to all of them, that's what you must do. If there's anything common to all 4 pieces, that's what you must do. The question was, because for the record, it doesn't pick up anything that picks up over there. Yeah, no, I mean, I can have a conversation with students, but the microphone won't pick it up. How do you know when to do it? It's if there is something common to all 4 pieces. It's not anything that is, like, oh, if I see an X, I got to do this. It's only if it's common to all 4 pieces that you have to do that. Okay? Now, the other problem is another one that you would not have seen before. It's AX minus AY minus BX plus BY. Okay? And again, being able to do these problems a lot of times is about being shown how to do it, right? Like it's not genetic. If it were genetic, then both of my kids would be able to do it, and neither one of them, well, my son probably can do it now, but my daughter has no clue. I mean, she don't even know that letters go into problems yet. They're still figuring out long division and that, fractions. She hasn't even gotten to where there's a letter in the problem yet. You would not know how to do this unless you've seen it before. The way this works is this. We're going to take out an A. We're going to split it down the middle. We're going to take out an A, and we're going to be left with X minus Y. I think that part should go pretty nice with most people. It's the next piece that gets you. Because what happens is, if you take out a B, you get negative X and positive Y, and then you're like, well, damn, that ain't right, because they're supposed to be the same again. What you have to do is not take out B. You got to take out negative B.
You take out negative A.
Well, you could have taken out a negative A as well, yes. It's the same thing. Negative B, I just think is a little bit easier, but it's just my personal preference. I'm sorry, there was a question about could you take out a negative a, and the answer is yes, you could have. It doesn't matter which one you did. Negative b, and then what do you have left? Negative b divided by negative b is 1, so that's just going to be x. And then positive divided by negative. Positive divided by negative is a negative y. And that's how you can get these two things to become the same, is by taking out a negative b here. And once you get them to be the same, what do? It's x minus y times a minus b. We good on that? All right. I'm going to stop it there.